hobby initially was a very steep learning curve for us. Like, and then amazingly, now it seems very easy. But just that beginning part, and part of it is just we did not, all of my friends knew visual astronomy, but they didn't know astrophotography. So I ended up having to do a lot of stuff online to kind of figure out, why am I not here? Yeah. And so, you know, I bet you there are a lot of people in town that would have been able to help. But the thing is, the setup that we have, and, you know, this turns out to be one of the worst pictures, I think, in the whole presentation, but at least that's my dad and Aditya and myself standing next to this telescope. And it was just, it's too heavy to easily just bring to star parties and ask people. And so we had to kind of look at online resources, of which there's a lot, and then sort through, because online resources, some of them are good, some of them are bad. And I will say that Aditya pretty much knows this stuff about as well as me at this point. And one that I want to particularly point out is galactichunter.com. They just have really good tutorials, and they just have a very similar setup to us. And so one thing that really I feel now that I should have known, but I did not know at all, is that I assumed that if we got a telescope, because as a kid, you know, our neighbors would show us things. I just thought seeing the planets and photographing them would be no problem, and all the deep space stuff is what you need the Hubble for. And it turns out it's kind of like, can be very much the opposite. And so the reason is, and I'll show this on the next slide, something that I just didn't know a lot about is how tiny planets are in the night sky compared to a lot of these deep space objects. It's something that I just didn't realize. And so planets, really, if you want to take decent pictures, I think you need about a 10-inch scope or better, and ours is an 8-inch scope. So we're okay to look at the planets really well. You can, you know, we're able to see Jupiter, you can see the red spot, you can see the moons doing transits, you can look at Saturn's rings, you can see the Mars ice caps. This is because you have an eyepiece that zooms way in. But when you're taking photos, you don't take the photo through the eyepiece most of the time. Therefore, the photos end up looking pretty bad. And the people who do a really good job on planetary photography, they don't do what I'm going to show in this talk. They actually use cheap webcams that just take a crazy number of pictures of the planet, and then it picks out the best ones, and then it stacks them all together, and you can get decent shots. But the thing is, it's just not going to look like, you know, NASA, which has been sending probes to our planets, and, you know, they're right there, and you're used to seeing those pictures from TV and so on. What really surprised me is deep space objects are actually pretty large in the night sky. And the next slide will show something that I think me and Aditya had no idea about. Yeah. The thing is that they're just really dim. And so, and the thing is there's just so many objects. I mean, you'll never run out of objects to look at. And, you know, you can get really high quality, high resolution and artistic shots that to me just blew my mind. And so these are two terms that I'll get into more details later, but the reason you need the telescope to kind of move along with the stars when you take these pictures is, as we all know, the stars are moving in the sky. They move a lot faster than I actually realized. And so anything more than 2 minutes and you're going to get lots of star trails. And you need to stack multiple exposures on top of one another. So you're taking a lot of shots, and then to reduce the signal to noise, you actually put them all together. I'll explain this too. And another thing that some people may be turned off by is a lot of these objects, if you just look through the telescope, you actually aren't going to see anything. You'll just see stars. You won't actually see the nebula or something like that. So this is, you know, this is the slide that I really somehow missed the memo on, you know, despite thinking I knew a lot about space. And I think probably astronomers know this, but I don't know if our audience necessarily does. So if you look at the full moon in the sky, you know that it, you know, it looks reasonably big in the sky. Andromeda galaxy is actually about 3 times bigger than the full moon. I mean, despite it being 2.5 million light years away, which, you know, that's how long it's taking light to get to us in Andromeda. It's so huge. I mean, it's 110,000 light years across. And so the fact that it is that far away, it's so big that it still is a bigger part of the night sky than the full moon. The reason we don't see it with our naked eye is it's just too dim. And the Orion Nebula, it's 12 light years across. It's a lot closer. It's in our own galaxy. And this is one of the brightest nebula we have. It's still, 1,300 light years across. And basically, away, sorry, and 12 light years across, thanks. And whereas if you look at like Jupiter, Saturn, and things like that in the night sky, I mean, I think we've all seen them. They're just dots in this picture. And then the Milky Way, which is our own galaxy, can actually fill up quite a bit of our night sky. And so that's the reason, deep sky photography from home can work really well, because you don't have to zoom in that much, and you can get, a full frame shot of something that's really impressive. And so I want to give a quick overview of the gear, and then I'll kind of go into a bit more details. So this is all things everyone can kind of look up on the web, but I thought I would just go through it kind of quick. There's different types of telescopes: refractor, reflector. Reflector it's cheap, and meaning it's fast means you can get it to let in a lot of light. That's what the F4 means. It lets in a lot of light. You have to often adjust those mirrors if you're moving the telescope around. And another thing that you're doing when you do a telescope, prime focus is what you want to do for deep space objects, meaning that you don't have an eyepiece. You're just basically using the camera as the eyepiece. And then DSLRs, which is what most people have if they're kind of a photographer, they're actually, the lenses for those work unbelievably well. If I had to start over, maybe we didn't even need the telescope to start. We could have just done great with lenses. And I'll explain this on the next slide. And different objects in the night sky are different sizes. And so sometimes it's important to take something at 15 millimeters, something that could be 800 millimeters. That's the range we cover. And so if you kind of go to this slide, you'll understand what I mean. Our telescope zooms into 800 millimeters. But what was kind of blew my mind is that the lenses we already went up to 600 millimeters, and they went all the way out to 50. As you'll see in the pictures I'll show later, there's all sorts of sizes out there. And so most people probably have the 50 millimeter lens. And for that, you don't even need to track that well, because you're zoomed way out. And so this website, telescopeas.com, lets you frame these different objects, when they rise, when they set, different seasons, different things rise, different things set. And so if you go back to this, the other thing you really need for astrophotography is a mount that tracks accurately, meaning that you need to be able to follow as the stars are moving across the sky, not because the stars are moving, but because we're rotating on the Earth itself. And so that means you need an equatorial mount. And then, as far as the camera, you could use DSLRs, but to really do well, you have to modify them, which means you have to monkey with them or give somebody else to monkey with it. Because what happens is DSLRs have filters that take away some of the wavelengths that matter a lot for astrophotography. And so the dedicated Astro Camera is actually something that does an unbelievable job, and I'll describe that. And so this is kind of the overall setup when we're just using our camera lens. And so I thought I'd just walk people through what this setup looks like. And so I think you can see my mouse. I mean, the first thing you need to be able to do is you need to be able to polar align the scope, which means that this thing needs to point to the celestial North Pole, which is where Polaris is. You might say, why are we doing that? It's because everything in the sky rotates around that point. And so if you look at if you actually took long exposures, and we actually want to mess around and take shots like this, they're not that hard to take, to get star trails, everything is going to rotate around pretty much Polaris, which is very close to the celestial pole. For astrophotography, you need to totally get this mount to basically point towards the celestial North Pole. If you have a permanent or semi-permanent setup, you can actually just pretty much do that and leave it as is. Otherwise, you have to keep redoing it. The other thing you want to have is See, you're actually balancing the camera, which is there on the top right-hand side. And then there's this Autoguider, which locks in on a star, and it basically makes sure any errors in the mount are accounted for. And so I think some of the things that I just had no idea would make such a huge difference that actually led us to believe we had all sorts of other problems were just like having, if any of these wires touch anything, you're going to completely mess up. If you don't balance the thing really well, it's going to be horrible. And by not cheaping out and not buying a cover and happily always trying to disassemble and reassemble, kind of made it want to be like, we didn't even want to go out there because it's cold and we don't want to assemble the thing. And we had to repolar a line. And so sort of taking that shortcut wasn't a shortcut at all. And then we started out with a telescope, not this lens, which means we're zoomed all the way in. So anything that doesn't do a very good job ends up looking horrible. And then you had to be in really good focus, because the one thing about astrophotography is every time you take a picture of a field of stars, if the star doesn't look like a dot, if instead it looks like a line, everyone's eye is drawn right to it. So you kind of know, like, oh God, that looks terrible, right? Because all the stars are just no longer dots. And so all of this might seem a bit intimidating, but it's actually not once you just figure it out. You just need to make sure your wires don't touch stuff. You just make sure you balance things properly. And then another sort of lazy or thing that we both got intimidated with was that we got this telescope and we have a great view to the south. You know, we can look at all sorts of neat objects in the south, but, you know, Polaris is to the north. And in order for this, you know, in order for this guy to point towards Polaris, that's pointing right at our house. So we can't see Polaris. And so what I would end up doing is trying to set up in our front yard, which is literally under a street light. And then the neighbors would be driving by and messing everything up, just because I wanted to polar align. It turns out you can do this thing called drift alignment, and you can actually do everything from the south just fine. The other thing that we really, you know, should have done much earlier is a thing called plate solving. When you tell it to go to an object, it doesn't perfectly go to that object. But if you enable this thing called plate solving, it'll iterate by taking pictures, and it'll actually frame your object perfectly. But if you look on the web, there's all sorts of people telling you plate solving is hard, whereas it took us like less than an hour to figure that out. So that might have been something to do with us being technically pretty strong, but not knowing anything on the astronomy side of things. Let me make sure I'm on. Yeah. So now I'm just going to flip through, and I don't want to go through all of these in huge detail, but I think people want to see the pictures. But this is the telescope that you would replace with that lens. And remember, that lens gets you out to 600, and this is getting you out to 800. But it makes a big difference because it's an f3.9, meaning it gathers a lot more light. So this is actually a pretty fantastic telescope, and it's about $500. And it's really good for looking at the planets, but not photographing them. But it's amazing for photographing deep space. And 800 millimeters, just by luck, happens to be in the sweet spot for basically filling the frame on a lot of really nice objects that you'll see. And if you move it around, you do need to collimate it, which only takes about, I don't know, less than 10 minutes or 5 minutes. And, you know, this lens we already had. I mean, we're wildlife photographers, and this lens is, you know, what we use to take the jaguar and the pantanal and so on. And, you know, it's not as fast. It goes from f5 to f6.3, but since you are taking multiple images and stacking, it just means you have to take more images. And so this is kind of a good dual use lens. Most astronomers don't really use a lens like this. They have another telescope to handle this stuff, but we found out that this lens does unbelievably well. And then we also have this wide angle lens of 50 millimeters. And I'll show you, there's a lot of stuff you can take with a wide angle lens of the night sky. And so this is the thing most people don't get. More than the telescope or the lens, you know, it's the mount that's actually the most expensive thing that you need for good astrophotography. And ours is actually one of the cheap ones. So this Atlas mount, it can support up to 40 pounds. I mean, basically, it's pretty heavy. And so lugging it just between our house and my parents' house is something that's not a big deal. But if you were going to star parties and all that, I think it starts getting to be kind of a pain. But there's people that have $5,000 mounts, $10,000 mounts, and those will track better. But as you'll see with auto guiding, you don't really need it to track better. So this is the camera we already had to do all of our wildlife photography. And the thing about it is, it's an extremely good camera for astrophotography. The thing is, you would either have to do it yourself, which is what the DIY stands for. And why do you need to modify it? It's because hydrogen alpha emissions are one of the main things that give you the pictures of all the nebula that you see and a lot of the colorful objects. And so if you just use your camera as is, there's a filter they've put in there that blocks almost all of that out. If you just go in and you remove that, have somebody else do it for $300, or you do it yourself, but you risk messing up the camera. And the other thing about DSLRs, which I was sort of skeptical about, but it's completely true, is that when you get to the summer months, see, we got this in the winter, it starts getting hot. And this actually results in like really noisy images on the sensor. And I figured, it's not that big a deal. It actually kind of is a big deal. So to me, this camera, I mean, it's not just me reading about it on the web and Galactic Hunter and all that. This is sort of what's really transformed things for all the amateur astrophotography, is cameras like this one. What it does is it basically comes with a filter wheel. And it's not even a color camera. What it does is you can take red, green, blue separately, or you can take different filters that different objects emit, which is either hydrogen alpha or oxygen or sulfur. Those are three of the main elements that actually light up things in the night sky. It also cools the camera down to minus 15 degrees Celsius. And you actually just have to, for those that aren't as familiar with just images are made up of red, green, and blue. So you basically just put the red, green, and blue images together and you have your color images. You could also assign red, green, and blue to these different filters, and I'll show you how that works. Now, this is the part where I'm on this Autoguider forum. Literally like 100 messages come in a day to these guys. This is free software that even I think NASA and so on does. What it's doing is it locks onto a guide star near the target that you're taking a picture of. And if you have a $10,000 mount, I think you probably don't need auto guiding that much. But if you have our mount, you do. And the thing is what it's doing is it's going to keep that guide star in the same place. So if the mount starts messing up, it'll send an instruction for the mount to correct. And what you see in the corrections to the mount is if you're doing a good job and balancing and no wire problems and you're not walking around near the telescope, it'll be nice and flat like that. It's just sending a few corrections to the mount. When we first started this, our thing looked like, some crazy number of waves for all sorts of things, like balancing it badly, windy, it's windy around here. And you go and try to debug and you can come up with all sorts of crazy reasons for what's wrong. Whereas all that was wrong is we didn't balance it properly, or it was, some wire was stuck. And so I think that was something that if maybe I worked with somebody who already knew what they were doing, this part wouldn't have been so frustrating. Another element to this, and I think maybe it sounds like these are all intimidating elements, but they're actually, once you nail any one of them down, it's actually pretty easy. So when you have a fast scope, which means a low F number and you're gathering a lot of light, the middle of your image is going to look great, but the edges of your image is going to look like what's on the left. It's called coma. Actually, the lenses we have, they're actually pretty good for not having it, but our telescope does. But if you put this coma corrector in, it fixes it. And then finally, being clueless, I just thought that you would just push autofocus and it would just focus on a star and you're good to go. astrophotography, I think unless you have some super fancy setup, you don't do autofocus. What they do is they just sell this really cheap mask that you put in front of the telescope, which is sort of designed to have the spacing that when you're on a bright star, you'll get these diffraction spikes. And you basically just change your focus until the middle diffraction spike is within the other two. If you don't do that perfectly, your image will end up looking horrible, but it's actually pretty easy to do. And so now I'll just kind of review. I mean, there's really not that many pieces to this. You've got an equatorial mount that's rotating to follow the Earth's rotation. You're auto guiding to correct errors in that mount. You've got your camera. In our case, we have this filter wheel, and just do a good job with the balance and the wires. You know, for example, balance might seem easy. You just want to get the weight down here to focus, to balance the thing up here. We always did that properly. But what we didn't do properly is, for example, the lens is heavier than the Autoguider. And if you don't balance that part properly, everything completely messes up as well. Yeah. And so, any questions at this point? Okay. And so now we're going to start taking pictures. And so I think for those of you that go to these PEEC planetarium shows, you could, you know, planetarium software on a computer, even if you're not doing astrophotography, is super interesting because you can pretty much zoom into different nebula and stars and globular clusters, and you can pretty much connect this to the telescope and it'll tell you exactly where your telescope is pointing. And this is where our lack of astronomy experience really hurt us. To align the telescope on a given night, you need to point it to at least one star so it knows where it's at. And this is where both me and Aditya completely messed up, and I think the audience probably would not, because I think many of you probably know astronomy better than me. We knew which Sirius and Vega and Arcturus was when we looked with our eye, but then when we looked through the guide scope or through the telescope, all stars kind of looked the same. And so we would end up like aligning on the wrong alignment star, and then the telescope pretty much would completely go to the wrong place. And, you know, so now but now I know every bright star, you know, no problem. And I know when it's going to rise, when it's going to set, and I feel pretty good about where we've come just doing this. And then, you know, using a computer nowadays, it's very easy. If you have a DSLR, you use a program like Backyard EOS. It's not so expensive. Sequence Generator Pro is just amazing. It'll put in the right filter. It'll go to the target. And then you have this guiding software, which seems to have like a following. Literally hundreds of emails a day come to that forum. And actually, it stands for Push Here Dummy. And so it's actually fairly easy to use. And then AnyDesk has actually come in kind of handy, because even if I have this thing set up at my parents' house and we're just home, we can see what's going on with the telescope. And actually, I can log into my parents' computers when they screw up something with their software or their Windows update, and I can do that too. So that's actually been kind of useful. And so I want to start getting to the pictures, because I feel like I'm going through, and this is more just to make sure people understand the different steps so they kind of have it for reference. But what you're going to do in a typical imaging session is you sort of figure out, oh, what's a nice thing in this time of year? You know, what is the focal length to be able to frame it? And then, you know, you would basically make sure the higher it is in the sky, the better, because you don't go through as much atmosphere and you're going to get a better picture. You sort of figure out how many subframes do you want to take to put together. Polar alignment, you can completely avoid that if you have a semi-permanent or permanent setup. Otherwise, you do it. Then you align on a star like Sirius, Vega, something like that. You focus, you run the sequence. And then another part of this is when you post-process these images, that's actually a lot of the fun, because you've got a lot of data, and how do you pull things out of data? And at work, I mean, we have all sorts of people trying to pull things out of data, and they're experimentalists and I'm computational. And it's actually been kind of fun because I sort of see things from their perspective. Some of the work that I even am doing is relevant to some of the stuff here. You know, Deep Sky Stacker just stacks the images together to reduce the signal to noise. You could use Photoshop if you already own it, but it's not perfectly designed for astrophotography. PixInsight is what everyone raves about. Even NASA uses it, and even NASA writes algorithms for it. It can do absolutely everything. If you work at the lab, you kind of know research codes are more difficult to use than professional software. This is still professional software, but it's more researchy than something like Photoshop. But it uses, you know, for the scientists out there, you know, multi-scale processing, deconvolution, noise reduction, sharpening. You know, it's able to do a lot of its processing when the image is linear before you had to stretch out the histogram. So what do I mean by that? You could do all the stuff I told you, and what you're going to get in your picture is going to be the stacked image. It's just going to look like what's on top. But all the data is there, because if you're taking raw images, it's all there. What you just need to do is you need to go through and stretch the image out, and then you can get the kind of picture that you have there on the bottom. And so I don't want to go into all the different steps for doing this, but I'll just leave it with, we figured that out fairly easily. Now I want to just say something that was also taught me quite a bit, and I think for Aditya too, is just what makes up our color images. I think most of us know that, you know, red, green, and blue can be combined to give you a nice color image. And each of, you know, blue has a range of wavelengths, so does green, so does red. And that's what we're doing with our eyes. And that's what, if you took just a picture with your camera, that's what you're going to get. But for astrophotography, a very important thing that really helps you is if you take narrowband images, which a lot of things just emit hydrogen and oxygen as those are getting excited and they're releasing certain wavelengths of light. And then there's also sulfur. And so the Hubble, they're often narrowband imaging, and I'll sort of show you what a difference it makes if you have those narrowband filters. So this is the Rosette Nebula. And, you know, if you tried to take this with our telescope, we're actually just zoomed way in. You would actually want to take this with like a 400mm lens. And, you know, if you just took it with RGB, you're going to get the picture on the left. And if you try to process it and do all that sort of stuff, it's going to be pretty noisy. So what the narrowband does is it picks up all the hydrogen emissions, and it knows the brightness. And you can basically map that brightness map onto the color, and you get these beautiful images that you see there. Are there any questions? I feel like without the chat, people are being kind of quiet, so I don't want to go too fast.
Just as a reminder, if people do have questions, unmute yourself and speak out.
Yeah, because I know with the chat, usually you get a gajillion questions, but I think without the chat, people are being shy. So, you know, for example, if you want to look at the Crab Nebula, this is a supernova fragment, and, you know, it's actually Messier 1. It's the first in the Messier catalog. When we first took this just with RGB, you just kind of, it still looks cool. I mean, you still get this cloudy area with different colors. If you then have hydrogen, oxygen, oxygen, you might ask, why are we doing hydrogen, oxygen, oxygen? And so the reason is, look where hydrogen alpha is. It's in the red part of the spectrum. Where is oxygen? It's sort of in this mixture between the blue and green part of the spectrum. So if you do hydrogen, oxygen, oxygen, you basically can get pretty natural colors of this deep space object, but what you will not get is the natural colors of the stars. Stars are actually super colorful. And so if you want to get like all the different colors in the stars, you've got to combine this hydrogen, oxygen, oxygen with the RGB, and I'll show you examples of that. And so these are the different color mappings that I'm going to kind of show you different examples of. What's going on? What time is it? Yeah, that's fine. Okay, so RGB, red, green, blue. That's what your typical camera is going to take. We all know that. Luminosity, red, green, blue, is basically going to allow you to snap on a brightness layer that's going to give you a lot more sharpness. You want to go sit there? And then hydrogen alpha RGB is really good for a lot of nebula. And then you'll see that a lot of the Hubble images you're seeing are actually hydrogen, oxygen, oxygen, or the famous Hubble palette, which is basically combining sulfur, hydrogen, and oxygen. Those are actually false color images. And I'm going to skip over this, and I want to sort of just get to what's the, what's hard and what's easy. If when we started, just to show you that it's kind of a steep learning curve, we would align our telescope on the wrong star, thinking we aligned on Vega or Sirius or something, and then we would go to the moon, and the telescope's not even close to the moon. And so just making your telescope find the moon actually turned out to be one of our harder steps. I mean, which might seem crazy to the astronomers out here, but because we're good at photography and decent at computers, but terrible at astronomy, that actually held us up quite a bit, just getting it aligned. And then make sure that you're perfectly in focus. Otherwise, things really end up being bad. And then moon is so bright, you don't need to guide or anything. And you can really, just looking at the telescope with the moon, you can get in all the craters and you can see some pretty amazing stuff. Milky Way, which is up right now, actually, if you have a view to the south, you can basically, this is like a 55 millimeter shot. This is pretty wide field, and you can get neat molecular clouds with different colors, and you can get that. This is not just a hazy image because of like clouds or something. It's just that's how many stars there are. Pleiades. I think most of you know the Seven Sisters. It's very easy to see with your eye. And so this perfectly gets framed with an 800 millimeter telescope. And so it's basically an easy target. If you just take a picture, you'll get the stars, but you need more than like 3-minute subframes if you want to get all these gases that are lighting up between the stars. And so, the nebulosity requires a little bit more effort, but just getting the stars is actually pretty easy. Globular clusters. This is also, they're a lot of fun because you can just look through the telescope and you'll see just such an amazing density of stars with different colors. And they're also very easy to take with astrophotography. And Hercules globular cluster is up now, and it's actually a pretty easy one to see with a telescope or with Astro. Now, Andromeda starts getting a little bit harder. So this is what our Andromeda galaxy looked like on a 300 millimeters is what's needed to fill the screen. And this is what happened with the DSLR and with Photoshops. But I've seen other people with DSLRs and Photoshop do better than we've done. If you look at Andromeda through a telescope, what you'll end up seeing is you'll just see the core of Andromeda. You won't see, and so you might be like, why is Hari saying Andromeda is so huge? I mean, it looks a lot smaller than the moon through my telescope. It's because you're just seeing the core, you're not seeing the whole thing. But if you move over to the Astro Cam and, we're better at guiding and we know how to process, I mean, to me, this is starting to look like the really good images of Andromeda that you see on the web. So any questions at this point?
Hari, I have a question about that picture of the Milky Way with Rho Ophiuchi and all the colors and everything. Was that just with a regular SLR?
This one I actually ended up connecting my SLR lens to the Astro Camera.
Okay.
But you could do just fine with the SLR for this too, but you won't necessarily get the really good colors on Rho Ophiuchi.
Thanks.
And Orion Nebula is the brightest nebula that's, I think, in our hemisphere. So if you look at it through the telescope, you'll actually see gases. You just won't see the color. And so this is Orion and Running Man. I think you could kind of see why it's called Running Man, because within those gases, you can see, kind of a man running. And, this is actually the DSLR picture. And you can see that since this is a fairly bright object, DSLR versus Astrocam is not that different. I mean, the Astrocam gets you a little bit more structure. It's a little bit more bright, but Astrocam doesn't make as much of a difference. And then Astrocam, and you can zoom out and you can get some really beautiful pictures of Orion. And I think it's just a beautiful, beautiful nebula. And the thing is when you look at pictures on the web, I always assumed you couldn't just get pictures like this just, from our backyard. or if you did, I thought it would be super hard. Now that we have it down, it's actually pretty easy to do. And it's pretty fascinating to know that this is light that's coming from, you're looking back in time, over 1,000 years, and you're seeing this amazing object. So now as you start getting a little bit harder, there's a lot of galaxies you can see at a pretty decent size. So, I mean, Bodhi and Cigar galaxies, I was pretty surprised. I knew Andromeda is close by, but I kind of assumed there's not much else we'd ever be able to take. But there's actually a ton of galaxies of different shapes that you can get. Now, you can even see interesting phenomena. So like whirlpool galaxies actually interacting with another galaxy. So when Hubble would show shots of this, I just assumed, well, that's Hubble. But yeah, we can actually see this kind of stuff ourselves, and it's fairly mind-blowing to do so. And then, the Hubble deep field shots that show like a crazy number of galaxies, I also, you can get this pretty easily. A 400 millimeter shot in this place called the Macarian chain is letting us see just a crazy number of galaxies. A lot of those are just like our own galaxy. So it's just really does kind of put perspective into things on, how many, I think billions of stars are in our own galaxy. And then as you start moving out to these other galaxies, and that we're actually able to see them. And so these are a lot further away. So we're really seeing light from very far back in time here. You can start getting some pretty interesting reflection nebula. And so this is, if you notice, to get a reflection nebula, you're not doing the kind of hydrogen alpha narrowband stuff, because what's happening is Rigel, which is part of the Orion complex, it's so powerful, it's lighting up those gases, and you basically need red, green, blue, and luminosity to bring this out. And the reason it's called Witch's Head, I think you'll see, there's sort of the, the chin of the witch, that's the nose of the witch, and that's the hat of the witch. Now, Roya Pucci is one of the easier ones to actually at least get somewhat, but to get all these colors and everything is a bit of a challenge. But that's really getting near the core of our Milky Way, and it's just a beautiful molecular cloud that has Antares, which is actually the laser fusion my dad worked on when we moved to this town. So it's kind of cool that Antares ends up being one of the neat astro targets for us as well. And then another one of these reflection nebula really does look like the iris of an eye. And, what you want to do when you're getting serious is you can get all the dust clouds and all these, all this structure that you can get. So those were all kind of these RGB, red, green, blue shots, that you might just broadband for the most part that I was showing. Now what happens if you have these emission nebula where it's really advantageous to overlay hydrogen alpha? And so to me, this one really blew me away that you could do this well on Horsehead. And so Horsehead and Flame are really nicely clustered together. For those of you that are used to looking at Orion's belt and so on, it's right there. It's too dim for you to see it. But Horsehead and Flame just come out beautifully. But if you didn't have the hydrogen alpha to basically overlay the structure and the brightness, this would look like some of those terrible images I was showing you up front. California Nebula. Amazingly, there's a nebula that looks very much like California. Again, you need that hydrogen alpha emission. And for those that don't understand why is that happening, basically the stars are exciting the hydrogen in this part, and the hydrogen kicks up a level, and as it comes back down, it emits light, just kind of like our neon lights and so on are doing. And that's the light that's reaching us. So if you just capture the hydrogen alpha, you get a really crisp image. If you tried to capture all of this in red, there's too much light pollution, even in a dark area, to be able to do a good job. Christmas tree, another one. It really does look like a Christmas tree. So now, if you go all narrowband, how do you end up doing? I was actually surprised you could do this. This is the Veil Nebula, which is a supernova fragment, and you're starting to get some amazing structure, and you can see that as the shock wave from the supernova is spreading out, it's exciting hydrogen in certain parts and it's exciting oxygen in other parts. And so you can actually learn, which I looked up all this stuff with Aditya, of, you know, how much oxygen's out there, how much hydrogen's out there. I mean, it's fairly interesting that water, H2O, is one of our big deal things, but hydrogen, oxygen are quite prevalent all over the place. You can also see another part of the fragment on the other side, which is called the witch's broom. And you can kind of picture this as a broom that the witch could ride. And then there's the Crescent Nebula. If you can see that there's a hydrogen center, and then if you look really carefully, you see the oxygen that's sort of ionizing on the outside of that. But the other thing that blows your mind is look at all the little dots. I mean, there's just a crazy amount of stars out there for us to see, and just so many gases as well. This is another one that, you know, really does look like a heart, and it's just a beautiful nebula, and it's huge. I mean, 300 millimeter lens is something that a lot of people own. If you track properly, you can get it. And if you tried to do this with our telescope, you would end up being way too close. And Lagoon, that's up right now. That's right in the heart of our Milky Way, and it's right in the southern sky. And in that way zoomed out picture of the Milky Way, which Rho Fuji, there was also Lagoon there. And then this one, I mean, our kid really liked because it's called the Eye of Sauron. So there's other than emission nebula, there's also what are called planetary nebula. And so when our star finally dies, it's not big enough to go supernova. It's expected to turn into a planetary nebula. Planetary nebula are a lot smaller in general, unless it happens to be really close. But this one happens to be one that you can actually get pretty well because it's just close enough. And so it really does look kind of like Sauron. And then Dumbbell Nebula. This is one of the first things we looked at because you can look at this one through a telescope and you'll actually see a fuzzy area of the sky, but you're not going to get all this structure and, you know, the hydrogen and the oxygen and so on. So now I'm going to kind of finish up just talking about Hubble palette, because I think a lot of people have seen pictures from the Hubble, and I never realized that they're taking a lot of times they're taking narrowband shots of hydrogen, sulfur, and oxygen, and they're actually putting these things together in false color images to sort of learn about the object and also to differentiate between different structure. And so the Rosette Nebula, if you take it with hydrogen, oxygen, oxygen, that's basically the natural color of this. But if you want to actually kind of see the different types of structures that are in this nebula, and you want to use the full set of wavelengths that we can see with our eye, you use the Hubble palette. And so you can see that, you know, there's a lot of amazing structure that you can see in the Rosette Nebula. And I think when Aditya and I first got this, he really tunneled in on Rosette Nebula, right? And he pretty much assumed, well, we're never going to see it like, you know, like we're showing here. We just assumed we'd see some fuzzy thing. But yeah, you can actually get unbelievable shots of this. I mean, these things you could print out at really big size and they're going to still look good. I mean, it actually, I'm reducing it in size when you're looking at it on a computer screen. And as you can see, the stars really are dots, and, you know, we've pretty much got this down. We've got the structure of the nebula, the stars are dots, and we're feeling pretty good about ourselves. If you look at it from the telescope, you don't get the full rosette, but you can at least get in and you can see all these almost like cracks that are in the gases. You can see those huge, powerful stars that are way bigger than ours. North American Nebula is very mind-blowing in the sense that really does look like North America, and this really does look like a pelican. And I'm gonna, for interest of time, just kind of flash through some of these. Heart is right next to one that's called Soul. Elephant trunk really does look like an elephant. I mean, this is the trunk and this is the eye of the elephant, and that's the forehead of the elephant. Wizard is sort of the symbol of a wizard, where you have the star and you've got the moon. And jellyfish, I mean, to me, this does look like a jellyfish in space. And then pillars of creation. We would always look at this from the Hubble and had no idea there was any chance of us seeing it whatsoever. It's part of the Eagle Nebula, and we can basically on the left, that's our picture of the pillars of creation. It doesn't look anything like NASA's. Actually, it does, I would say, look like NASA's iconic shot in the sense that you can see the three pillars, and this is a stellar nursery. You're not going to get it like NASA because they can zoom in more in their NASA, but we can still do awfully well. And then I'll leave with, you know, because you have the tracking and because you can put this stuff together, you can now start stitching parts of the sky together. And so in this case, there's a whole thing called Barnard's Loop, which is all of us look up at Orion, I believe, like in the, you know, in the winter months. But this is what Orion would look like if you actually, that's Orion's belt. If you basically had, you know, if you had the sensitivity and you didn't have light pollution, that's what the sky would look like. And you can stitch that together and you see Orion's belt, Horsehead Nebula, Orion Nebula, and Barnard's Loop. I mean, to me, this picture just blew me away. And then if you zoom out even more, look at everything you see. Betelgeuse, this is right around when they were thinking it might go supernova, and you know, it's completely changing. I mean, you could see it changing day in and day out in brightness and so on. Witch's Head that I showed you before, Rigel, you know, you're really able to see a lot of stuff. And I'll just quickly say, this is really a whole supernova fragment. That's where the supernova would go off. And you can see the parts blasting away, and different parts are ionizing gases. And, you know, the kind of structure that you're able to see, it's actually pretty darn educational and visually fantastic. And then finally, Rosette. Rosette and Christmas tree can actually be put in the same area of the sky as well. North American and Crescent also fill the same part of the sky in Cygnus. And this has also allowed us to combine hobbies. And people mostly know me for all the wildlife photography. And you can take long exposures for the background and short exposures and flash for the foreground. And you can actually fill the star with sky. You know, there's star in the background and you've got the cougar coming in the background. Water gardening's been a hobby. And so in a way, 3 hobbies that have sustained our family for a very long time have all been combined for this image. And then very quickly, all of you can do this one. I mean, the comet's really easy to see even with the naked eye. Before it was at dawn and now at dusk. If you just look at it around 10:30 at night, 11 o'clock at night, you can see it pretty easily. And if it wasn't cloudy, it clears up. Even though it seems like it's monsoon, it will clear up a lot of times. So last night it was visible. And I would say in another week, it's going to be really good. It's already really good. So I'm just going to leave you with this was sort of just meant to give people a taste of what can be done, you know, by people who just sort of figured this out for about a year and a half. And so for everybody, it's going to be different. We love photography, so we really went all in on that. And, you know, we were pretty patient. And the planets, we figured we might just get good photos of Jupiter and Saturn, and that pretty much run out of stuff to do. Whereas deep space is just this endless thing. And so, you know, if you have a semi-permanent setup, a lot of people probably do around here because there's just a lot of good views, you could really have a pretty easy setup. And, you know, social distancing has sort of made this even better because there's just not too many other activities going on. And Los Alamos is special for this because of the high altitudes and the stars. There's so many good, I assume probably much better astrophotographers than us, and definitely way better astronomers. But I think just even though we knew quite a bit about supernovas and all this sort of stuff, when you actually see it and where they are in the sky and know which stars are in the sky and what's going on, it kind of opened up a whole new world. I mean, when you're out there looking at the stars, now I pretty much know where everything is, and so does I. Yeah. And so we were going to have him say more, but it's actually, some of this is hard to explain, but I will say that he's picked up most of it right along with me. And it's just been a wonderful hobby. So I hope it was sort of blasting through a lot of stuff, but I've heard by the moderators that this audience is fairly technical and you don't want to keep it at too high a level. So I just kind of tried to bridge a bunch of different levels, and I'm hoping, even though there haven't been a lot of questions, that you did get a lot out of this. But I'll leave it open. I know I've sort of taken up most of the time. Thanks.
Thank you, Hari. Those are amazing. And does anybody have any questions? Just unmute yourself and speak out. Since we don't have a chat button, we're going to have to kind of jump in.
Hey, I have one question. Do you have to do anything with the light pollution? Like have to, I don't know, try to subtract that out of any of the images?
Yeah, I didn't go into that. But yes, so there's a few things. The narrowband images don't care about light pollution. They're really, and then the fact that the camera cools down to minus 15 degrees Celsius, the camera we have, that it eliminates an enormous amount of noise. But what we do is you can also take a bunch of what they're called darks that basically take pictures of the noise, which you can just subtract out. And it used to make a big difference for the DSLR, but for the Astro Cam, it doesn't make nearly as much a difference. The other thing to point out is I really have become aware of when the moon is out, because if you want to take RGB pictures, the moon ruins them completely. But the narrowband images of hydrogen, oxygen, and sulfur, they don't even care about the moon. And so what you usually do is you take your narrowband when the moon is out, and when the moon is mostly not that prevalent, you take the RGB. But yeah, the Astro Cam has gone a long way to making the noise stuff not as bad.
Hari, that picture of the cougar in the Milky Way was, or I guess it wasn't the Milky Way, but cougar and starry background. Was that all one image, or was that a bunch of images stacked?
So yeah, good question. So, you know, the way we got this idea is like at LANL, we had a director's colloquium by Tim Lehman, who's National Geographic Photographer of the Year. And he looked at my mom's pond, Warbler Pond, and thought it was like almost like a National Geographic caliber location, just because you've got the canyon in the back, you've got the stars in the background, but I was never taking advantage of any of that. What he said is if you fill the foreground with flash and then take the background with a long exposure, you're going to get amazing shots. And so what I usually do is I'll take a few long exposure shots of the night sky around that time of year, and then I will combine it with the foreground. But then I've also gotten images of things that are, you know, not as rare as a cougar, where I can actually get it in real time. It just does the flash and it'll take a picture of a raccoon and you'll get the stars just like you see. But the cougar comes around about once a year. And so that had to be a shot that was merged.
So I understand Canon used to make, I don't know if they still do, some cameras that were specifically for astrophotography that were DSLRs without the filter. Have you ever tried those or heard anything about how well they work?
Yeah, so I mean, basically what I did look into that, because all our other cameras are Canon and it's tempting to do that. But well, basically what they're doing for the most part is removing the, you know, that filter I was talking about, so that the Canon would now let in the hydrogen alpha. And so the thing is, if you want to do Hubble palette, and if you want to see like all those, like Veil Nebula was one that both of us just love, because there's just so much like intricate detail and you can't get it unless you have oxygen. And, you know, for a lot of these other ones, you need sulfur. And so the filter wheel is needed. And the Astro Cam, it's not worth it, because the Canon camera ends up costing just about as much as the Astro Cam does. And the Astro Cam already comes cooled and it comes with all those filters. And so I would advise, from what all my people that I now talk to on these forums, the Astro Cam is so specialized and it's just perfect for astrophotography.
Hari, you modified your own Canon to take out that filter. Was that a hard job to do?
So actually, we had two Canons, right? So in a way, I felt like you could mess around with one of them. But then I looked at what it took to doing it, and it looks like if you have any static electricity or something, you would fry the entire camera. And so I would say this is one of the things I really feel like we didn't do a good job on. I didn't talk about the baby steps that we tried to take. We tried to start out with the Canon just because we're used to Canon cameras, and we went and gave it to somebody to modify and spent $300 And then it turns out the Astro Cam, I mean, once you add it all in, you get the filters, you get the camera, you get the cooling, and it's easy to use. I should have never modified the Canon because the other thing they don't tell you is when you put on a clip-on filter to a Canon to basically take the hydrogen alpha, you have to refocus. You can't just leave it as the same focus as you do for the regular light. And so refocusing takes the fun out of everything, because once you're on a target, you've got to like slew over to a bright star again. And then you also have to, you have to slew over to another bright star. You have to then refocus. Hydrogen alpha cuts down most of the light. And so bottom line, I'm all in on the Astro Cam, and I think it was a baby step that I should have never taken to use the Canon. That's what I would say. And then also another big mistake was to not do plate solving right away. There's all these people on the web that make it sound so hard, and Aditya and I figured out in less than an hour how to do it. And every time now, it perfectly centers the camera. Before, we'd be sitting there hunting for the object for like literally an hour, and that starts getting frustrating on a cold winter night. Oh, I've got a question here on one of my friends that texted me. So how do you focus? This is a good question on NeoWise, because I think a lot of people would like to take a picture of the comet, or space in general. How do you do it just when you have a normal camera? So what you could do is just very easy, is during the day, you can just focus really far away when it's bright, and then you're focused at infinity. And then you just shift the thing over to manual focus. And if you want to be super careful, put a piece of tape on your camera so that the focus doesn't move. And then you're pretty much, you just want to be focused at infinity. You will find out that if you try to focus at night on NeoWise, there'll be nothing to focus on at infinity unless we have enough light pollution to focus on some bright light. And so that is the way to do it. And that's actually a really good question. People have been getting frustrated because they just don't know how to focus on anything at night. So just focus during the day and leave it that way. Any other questions?
Yeah, I'm not sure how you, with the Astro Camera, how do you put lenses in front of it?
Oh yeah, so I'll quickly show you that. So basically, the Astro Camera is kind of just like a DSLR camera. It just comes with a fitting that'll fit any Canon or Nikon lens. And so it's actually fairly straightforward. I mean, what's not going to happen is there's no autofocus capability or anything. But yeah, all you do is get literally like a $15 adapter, and then you can connect. God, I got to go all the way back here. Yeah, so if you see there, the Astro Camera is just hooked up to my lens just through the Canon adapter. So I've got my Astro Cam, which goes through the filter wheel that goes through the Sigma lens. And it's kind of funny that the Sigma lens is what we're using to take Jaguars, and it's also what we're taking. I would say 2/3 of the pictures I showed you are not with the telescope. And it's way easier to do it with the camera because lighting, things like that are just so much more forgiving because it's just so much lighter. So the mount has a very easy job to do. So even if you don't balance it that well, the mount can handle it. When you stick the telescope on there, you know, you're zoomed in more. And so we started out kind of at the deep end of the pool, not really knowing. And so that picture that, I don't know, maybe all of you might know because you know astronomy better than I did. But yeah, a lot of these objects are huge. I'm actually curious for the audience. Did most people know these objects are huge? Do you know they're all just floating in the sky like that? And it's just the reason we don't see them is not because they're too small. It's because they're too dim. Is that kind of a well-known fact? Because neither one of us had any idea. And my wife didn't either. Yeah, well, I think Galen, I'm not surprised, knew that one. Any other questions?
I think you have a mixture. I think probably a quarter of the people have heard these kinds of things enough that they could figure that out, whereas three-quarters probably hadn't heard that before.
Yeah. Yeah. And I mean, I guess the other thing is just simply much like I started out with wildlife photography, I never really wanted to do it because I just assumed it would be impossible to get anything decent. And then, you know, it turns out you actually can. and so, yeah, astrophotography in Los Alamos, I think if we were at low altitude, these pictures would turn out quite a bit worse. Or if you're in a big city, you could do the narrowband pretty well, but still, I think it still helps a lot to be where we are.
There were a lot of dollar signs throughout the presentation. Is there a total amount for all the software and everything?
Yeah, I said about 5,000 because I mean, if you did, for example, if all you wanted to do is not worry about the telescope, right? You could get a much cheaper mount than this because then it wouldn't be heavy. This mount is what costs close to, I don't know, I said $1,600. You could get a much cheaper mount. And if you already have lenses, you've already saved that money. And then you pretty much just need the Astro Cam. And it really depends on how gung-ho you are, right? I mean, if you want to take the Milky Way and you want to take globular clusters and you want to take the brightest objects, you could easily do it under $1,000. But I would say our $5,000, I think, gets us a pretty advanced setup. That's super easy. I mean, now, if we just want to take objects, I mean, it literally takes me about 10 minutes to set the thing up because it's just, and it's really fun because you decide, oh, will this object be best in narrow band? I mean, how do I bring out the star color? Is this going to be a good mosaic? I mean, we plan it out during the day. I mean, for the winter, you know, I always say, like, you're going to like winter here if you learn how to ski. And I think if you get depressed over dark nights, I think you won't if you pick up astronomy. You actually look forward to the dark, long nights. Any other questions?
Okay, well, I've got lots, but let me try one more. I think you mentioned it, but you went through it too fast for me to catch, and that was the focus on the Astro Cam. How do you do that focusing?
Yeah, so basically what you do is the camera is hooked up and you're on it. You're basically got to align the telescope anyway. So the way you align it is you just say, go to a star that's bright, which is like Vega or something like that. And so I think for most people, that would have been trivial. For me and Aditya, it turned out to be one of the hardest things in our whole process because we would just aim at the wrong thing. But assuming you're on the bright star, if you put this Bahinotov mask on your telescope, it's going to be different. This is for an 8-inch telescope, this Bahinotov mask for $15. What it is this pattern is spaced so that you will get diffraction spikes on a bright star. And so as you're focusing, what'll happen is that middle spike will move. And so if you put that middle spike in the middle, you're done. And the other thing you could do, like you might ask, well, you said 2/3 of your pictures are with the lens, not with the telescope. And it's true, we didn't bother with the Bahinotov lens. But all you do is you're on that bright star and you just turn your focus and the computer will tell you a number. And you just want to make that number as low as it can be. So as you keep changing the focus, the number will decrease and it'll eventually increase. And that's when you know you're in perfect focus. And so initially, I think one of our biggest problems is we were just sloppy. I mean, we had cords that were hooking on to everything. We were walking all over our deck, not realizing it made any difference. We were not in perfect focus. I mean, if you look at this picture and you look at the inside focus and the outside focus, those don't look that bad, right? That middle spike looks kind of like in the middle, but it would be a horrible picture if you did that. But if you get it in the middle, it'll be amazing. And so it's actually, I mean, I don't know, some of the people who work with me will know what I do for a living is debug code. And this is actually the same thing. I mean, once you learn to debug the most simple things, it becomes kind of a very easy hobby. So Rick, if you had more questions, go for it, because those are good ones.
Yeah, I was just wondering how you use the Bahinotov mask with the DSLR lenses, and now I know you don't. There's a software system that gives you that comes with the camera, presumably, or that you mentioned in your other slide, that gives you a number for the point light.
Yeah, I
focusing.
mean, there's just, it was hard. And I mean, when I went through this talk, I sort of got myself into what have I gotten myself into? Because actually all of these pieces have little details here and there. But when you set up a sequence, you basically, you align the thing, you focus it. When you say you want to focus it, it'll right away be on the bright star. The software knows to give you a number associated with that bright star. And as you move your focus manually, that number will dance around, and you basically just minimize that number manually. And there's all sorts of people that like go and get automatic focusers, automatic rotators. I mean, these things cost like maybe like $1,000 and stuff. And I don't know, basically I can do this procedure now and I can focus in less than a minute. So it's actually really easy once you get the hang of it. Initially, it just seems daunting.
I have a question about photographing the comet. Since it moves with respect to the background stars, is that going to be a problem? Can you still guide on a star?
So yeah, okay, that's a good point. I mean, I should mention the comet's super easy. I mean, all you need is like a 2-second exposure to get the comet and its tail. Like anywhere from 2 to 5 seconds, ISO 1600, maybe about a 200 millimeter lens, and you're good. I mean, and I think that the more interesting pictures of the comet are the comet with the canyon or the comet with Los Alamos lights. I mean, you could zoom all the way in and there's no need to do tracking or anything because it's bright. I mean, you can see it with the naked eye. And I think this is sort of not that common to have a comet with such a nice tail that it's beautiful. I mean, it kind of blew me away when I first went out there and I could just see it with my naked eye, because I think a few days earlier you'd need binoculars, but now you don't even need that. You can just see it. And so no tracking, none of that's needed. You do need a tripod. And I guess for people who are asking me some questions by text, you do not want to, for a 2-second exposure, you don't want to just push the focus button. Because when you push the focus button on the camera, you disturb the camera. So you sort of want to do a remote trigger. So if people don't have a remote trigger, that could completely screw up your picture. And so you should, I have a remote trigger, so I haven't really thought about how to do it without a remote trigger.
For what it's worth, when I took pictures of the comet, I would put the self timer on for 2 seconds, and then I'd push the button, and within 2 seconds, it settled down enough that it seemed to work fine.
Good idea. That yeah, I forgot. That is what you would do without the trigger. Yeah. But yeah, the mistake people make is, I mean, even I made this. I didn't bother to look up what people were doing. I proudly took an exposure of like 30 seconds on the comet. I got a beautiful tail, but yeah, the comet looked horrible. It wasn't, I sort of got it trailing. I guess it must be, maybe others can answer this. I guess it's moving faster than the stars as far as in the night sky, because yeah, anything greater than 5 seconds in the picture did not look good.
Yeah, so it depends on your the number of millimeters of the telephoto lens that you're using. So for example, the star trails and the head of the comet will be fairly close to moving over a few minutes, about like the stars do. And so there's a formula that different people have different formulas. But if I take 5,000 divided by the focal length of my lens, that gives me the number of seconds that I can, actually maybe it's 4,000 divided by the focal length of the lens, that gives me the number of seconds I can use for the exposure. And the bottom line, if I get the right number, the bottom line is for something like a 15 millimeter lens, you can take a 25-second exposure with a DSLR, but for a 300 millimeter lens, your maximum exposure is less than a second. So if you try to do a 30-second exposure, everything is smeared.
That's probably what happened to me because I was around 200. Yeah, so I mean, I'll just say that this is a pretty good season. I mean, it's nice and warm, and the Milky Way is to the south. The planets of Jupiter, Saturn, I mean, they're all really with good visibility. I mean, the monsoon will kind of mess it up for a while, but usually the fall, I think, is one of the best seasons. I mean, once you get to end of August, there's no wind, and it's a really nice time of year to get all sorts of neat stuff. But the comet should not be missed.
Yeah, let me correct that real quick. It's like 400 divided by the focal length of the lens, not 4,000. Sorry about that.
That's fine. Any other questions? Oh yeah, so I guess the F number for taking the comet, you know, I guess I did mess around with it. I thought that opening up my lens to 3.5 was doing okay, but I think you could probably get away with higher F numbers for more, but I don't know if the depth of field is going to help, and maybe someone else could help me with that. Does a higher F number help to take this comet?
I think you pretty much want as much light as you can get if you're not guiding.
Yeah.
So my experience was I first tried with an f1.8 lens, and for even a few seconds exposure, my house it wasn't when I built it, but it is now surrounded by 4 streetlights, and all I got was washed out everything. So I went to f2.8. That worked pretty well for a 2-second exposure. And then I went to with a higher, I had used a 400 millimeter lens, and that had an f4.5, and that worked just fine, for a second or 2 exposure. So it depends on how much light you have around you. If you have a really dark sky, the wider open your lens is, the more you'll get background stars and other things. So you also might get a little more coma. So if you stop it down like 1 f-stop from the widest you have, that's probably the best your lens will do, and at least in my personal experience.
And I guess for people who aren't that used to it, I mean, even if you go and take a picture an hour after sunset or an hour and a half or whatever it is, even if it looks pretty dark, I mean, the camera is pretty sensitive. So you're still going to see kind of like nice sunset colors and stuff like that near the horizon. And so it makes for some, and it's actually cool when there's clouds around with the comet, to get some scale and actually getting the mountain and the comet together. I mean, there's a really cool picture at Overlook Park when it was there in the morning. I was actually thinking PEEC might be a good place. At least that's what my wife said. The view from PEEC would get us a good northwestern view with the city and the mountains. That would probably be a pretty cool shot. I don't know. Are you allowed to go to PEEC at night, Rick, or will the alarm system do something?
As long as you don't go in the building, if you're just on the outside.
Yeah.
I don't see why not. I mean, technically it's county property, and you may get questioned by someone about why are you wandering around the PEEC building, which is closed at night. But I don't think you would really get a lot of hassle for it. And if you do, have them call me, since I'm the president. I can probably speak for PEEC.
Yeah.
I was there last night actually at the PEEC watching the comet.
Is it good?
It was good, but like towards like around 10 p.m. it's very close to horizon, and there are trees that blocks the view. But around 9:30 the view was amazing.
Okay.
Hi, I just wanted to thank you a lot. I'm not quite as far along. I'm doing the same thing from the Santa Fe area, and I just wanted to point out a lower entry cost way is the same Astro cameras as a one-shot color. They really are good, much better than, I'm using the ASI 2600. And Sharp Cap, which does the stacking in real time, and that's free, or $20.
Yeah.
But I really wanted to thank you, because now you've inspired me. I was kind of afraid of the filtering and the combining with the PIX Insight. So you've encouraged me to go out and give that a go. I did not have the desire yet to try to put the filters together. One question is there anything you can do from a citizen science standpoint at the level that you're at or we're at in terms of astrophotography? Is there any citizen science that can really be done? Thank you.
It's a good question. I've wondered about that too. I mean, I haven't come up with anything. I mean, I do think that it's a really educational thing for kids. I mean, now my kid really does understand the concept of so much stuff. I mean, like, how fast does light travel? I mean, how far, that we're just this tiny planet in this, solar system that's part of this enormous galaxy. And then there's a gajillion galaxies out there. I mean, it really does put things in perspective, when you think about a lot of those stars probably have planets and things like that. And so I just think that as a kid, I was pretty space crazy, and my dad, worked on the space program, and he took me to the last space launch and everything. And it's certainly, space has been a big part of my life. And I kind of thought I knew it pretty well. But when I went through this hobby, when we both did it, we felt kind of like, oh my God, there's like a ton of stuff we didn't know. And so I think you mean citizen science, maybe like making perhaps discoveries or adding things to a cloud. I mean, I just think from an education point of view, this really does permeate a lot of stuff. I mean, for example, like even how you focus these stars helped me and some of the experimentalists at work on how we track particles through porous media for the work we do. Some of the ideas I was messing around here, we were actually doing at SINT at LANL. And so I just think it permeates a lot more than people might realize. I mean, when you have the planetarium at PEEC, you have planetarium software, but then you're out there pointing the telescope and you actually see that's where that object is, that's how big it is, and those are the elements that are out there. And now my kid knows how much hydrogen, how much oxygen, I mean, how much carbon, all these different things that basically we've ended up learning way more than I ever thought I was going to learn. So it turns out there's a lot of stuff I didn't know. I mean, I kind of figured he wouldn't. I mean, he's 10. But sorry, I don't know. I think you might have meant something slightly different, but I just think it is really educational. And I'll also say one other thing. I mean, the one-shot color is a really neat thing. PEEC's Insight, yes, it's intimidating, but if you just buy the book, I mean, if you email me, there's a book on Amazon. If you just have that book, PEEC's Insight becomes very easy. I think without the book, it's impossible.
But is it very easy for a programmer, or is it very easy for anybody?
I think it's hard. That's where it's hard for me to tell. I would say that it's should be easy for most people that are somewhat technical.
If you don't mind, I can drop in a little bit on the citizen science part. If you just Google citizen science with telescope or with astrophotography, what you'll find is a whole bunch of websites, and they talk about projects. And some of the projects are things like helping to look for exoplanets, detecting supernovas, looking at various kinds of nebula kind of things. There are some where they'll coordinate people taking photographs at a certain time within your time zone, and do that for people across the world, for example. And then you send your images in and they combine them together and stack them and look at time dependencies and things like that. I was involved in one of those, and so was Galen when we did the solar eclipse a few years ago. So there are those kinds of projects out there, and a Google search on citizen science with astrophotography will build up quite a few.
Thanks,
I also have a comment on the citizen science. If you look into the AAVSO, the American Association of Variable Star Observers, I think there's still a need for people to do variable star observation photometrically, and you might be able to do that with the photography setup like this. And just a couple of days ago on Science Friday, somebody was talking about a project that's looking for records of satellites because they're worried about some of these satellite constellations that are going to go up and create a lot of light pollution and problems for astronomers. And they want to get people to help document that. So that might be another thing.
Yeah, I mean, I could quickly add, I mean, PEEC's Insight does have all these kind of astrometry kind of scientific. One of PEEC's Insight's philosophies is not to, you know, just make a colorful mess out of everything, but to actually represent oxygen and hydrogen with the right colors. And, you know, if your stars are not circular in your image, it's not just going to go and try to fix it for you. And so, yeah, PEEC's Insight actually has a lot of people use it for scientific purposes, for sure. And then, yeah, I don't know if people have seen those, like the Elon Musk satellites going across the sky. You can see these beads of satellites going through, and, you know, sometimes you can think that's pretty cool, and they could also completely mess up astronomers at the same time. And so I guess.
Actually, I should ask, have you had any shots that had unexpected satellite trails?
Yeah, you get all sorts of trails. I mean, there's like parts of Orion, and oh, you might ask, I mean, this is something I didn't bring up. I mean, why are we taking kind of like 5 to 10 minute exposures? You could ask, why am I not taking like 30-second exposures, you know, 1,000 times, and basically, you know, just stacking that, then you wouldn't even have to track anything. The answer to that is there's a thing called read noise and stuff like that. You just don't get enough photons, and that just isn't going to work. If you try to take like a 1 hour exposure, you're going to get a lot of meteorite trails or planes, or it's amazing how many subframes get messed up due to something passing through. It's not at all rare. I mean, if you could be certain parts of the sky, and, you know, I don't see that many meteorites or shooting stars walking around, but when you do this, you get tons of them. And so 5 minutes is sort of the rough time where you get enough photons for a good subframe. You don't have that much read noise problems. You know, it's a long enough exposure, but then at the same time, you don't mess up the whole frame because something went through it. It happens a lot.
Hasn't the community missed the chance to stop all these satellite clusters? Because it seems to me it's too late now with Elon and everybody else with their plans and all the bucks that they've got. That's happening. It's too late.
Yeah, that's something I don't actually know much. I would agree. It's probably not easy.
They've got the money, and
Yeah.
it's already. I mean, I'm afraid that ship has sailed.
Yeah. I mean, I guess not that, but I mean, maybe Rick or PEEC kind of has like a dark skies initiative type of thing, right? I mean, even New Mexico is sort of doing a dark skies initiative to attract tourism. I mean, before all this COVID stuff
Well,
shut
but
everything
the thing
down.
is the dark skies from what's being produced on Earth versus the illuminated star background that all these satellites.
Yeah, that I agree. I think that ship may have sailed. I'm not sure. Yeah.
Well, there is something that has been done about that, and that's they've persuaded SpaceX to launch their satellites into higher orbits, and also to paint them black. I mean, I agree. It nevertheless is deleterious to our views of the night sky, but it's they do listen to us. And you know, there's also a European program that's going to be sending a whole bunch of satellites up also, and since they're coming, you know, late to that game, they're going to do a better job of it too. The reality is that we have got a lot of space junk up there that that interferes with all kinds of things. You know, as Harry was saying, it's very hard to take a decently long exposure picture without getting tracks of some kind in it. And regarding the Dark Sky Initiative, yeah, we're very actively working together with the two units of the national park that are in our neighborhood, with the Pajarito astronomers, with the Santa Fe stargazers, and with the International Dark Sky Association to get new lighting ordinances and to enforce the ordinances that we have. So we're working hard to kind of preserve our interest in the night sky.
Okay, well, I guess if anybody, yeah, a lot of good questions. I'm glad there's a lot of questions since, any others?
Well, it looks like that's all the questions. Thank you so much, Hari. This was a wonderful presentation. I really enjoyed it. And everyone,
I hope I hit the high points anyway. And I would say the main thing to everybody is don't get intimidated, because I did get intimidated. And, you know, the beginning part really seemed impossible because we're like, oh my God, we can't even find the moon with our telescope, right? I mean, that's literally where we started. And we did get stuck. We couldn't do anything for maybe a couple of weeks. But then once we got going, I feel like we almost took too many baby steps. We should have just gone for it and just gone all in, and we would have gotten there even faster.
well, I have to admit, I'm still a little intimidated, but I think we can all take that advice under consideration.
Yeah.
And everyone, if you'd like to join us again, please visit the PEEC website, peeknature.org/events for more information on upcoming talks. Next Friday, Paul Arendt will discuss dwarf planets. So thanks again for tuning in. Thank you, Hari. Thank you, everybody, for tuning in, and good night, everyone.